This is the Module 4 Mastery assignment. My name is Caitlin Stewart, and this is for AP Calculus AB. So out of the two topics that we had to choose that were the most important for this module, the first one I chose was antiderivative techniques. So there's some definitions we need to go over first. First of all, the constant of integration is the constant, and the variable is not the variable, the letter is c that is used, added to the antiderivative to represent all functions that have the same derivative. And when these functions are graphed, they graph as vertical shifts of each other. The next one is antidifferentiation, which is the process of finding a function that has a derivative equal to the given function. The general antiderivative is the family of functions that all have the same derivative function. And antidifferentiation is the process of figuring out what function differentiates to a given function. So there are some rules, and these are the techniques that are really important to learning and understanding and how to work out these problems. So I will read through the ones that I think are the most important out of these, and then the rest you can kind of see on your own. So the ones to the left are the general rules. So these are things like the constant rule up here, the power rule, the natural log rule down here, the exponential function rule, the product rule, so those kind of things. And over here are the trigonometric functions and the inverse trigonometric functions. So this is things like the derivative of, or the function would be cosine x, tan x would be equal to secant squared x, and then down here are your three inverse trigonometric antidifferentiation rules. And so this would be 1 over the square root of 1 minus x squared, negative 1 over the square root of 1 minus x squared, and a positive 1 over 1 plus x squared. So no square root down here on the arctangent. So here's some examples, or one example in specific. So this is a very general example of how this would work, and it is asking us to find the antiderivative of x to the fourth plus 3x minus 9. And here's our answer. So using the power rule, since the fourth becomes the fifth if you have the original function, and then it needs to be divided by the 5. So it's 1/5 x to the fifth plus 3, and then this becomes x squared. So the 3x gets divided by 2 also, so it becomes 3/2 x to the x squared minus 9, so that becomes minus 9x. And this is really x to the first, and which means that this entire thing, the negative 9x, is divided by 1, but since it's divided by 1, we don't really have to show that. And then the plus c is on the end to indicate that it could be any variation in that family of derivatives. The second topic that I chose was the fundamental theorems of calculus, of which there are really two parts. So part 1 is the fundamental theorem, which is the rule that links together a function and its derivative, or a function and its antiderivative. So the definite integral of our rate function f of t on an interval is exactly equal to the total change of its antiderivative on the same interval, which basically is to say that the definite integral of a function over a interval, like from a to b, is equal to the total change of its antiderivative on that same interval. And so this is the equation that kind of shows that. So it's the integral from b to a, sorry, that shows kind of weird, of f of x dx is equal to capital F of b minus capital F of a. And so that's just to say f of x is your antiderivative, and this is your original function, and they're equal. Part 2 is a little bit different. In this side, so first of all, we have to create, we have to give our definition of an area accumulation function, which is the function wherein the variable is within a limit of integration, thereby causing the definite integral to vary in the amount of area accumulated. And so this means that the input value of g of x is a limit of integration of f, and the output value is a definite integral, which is a number representing the net signed area bounded by f in the x-axis between a and x. And so this is our new equation for part 2. G of x is equal to the integral from a to b for f of integral from a to b of f of t dt. So let's try this out. So sorry, it's a little bit blurry, but if you have capital F of x, which would be your original function, now it's asking us to use capital F of pi, which means that x is standing in for your pi, would be equal to the integral from from 0 to pi of sine t dt. And so this pi would have originally been an x, but since our x's are being replaced with pi, that now becomes from 0 to pi. So to solve this, it looks like this. So the antiderivative of sine is negative cosine, so that becomes negative cosine t from 0 to pi. And simply we use our equation, and we have negative cosine of pi minus the negative cosine of 0, which is just 1 minus a negative 1, which is simply 2. And that concludes my presentation. Thank you for listening.